Okay, continuing with vectors.
Yeah, drop all your stuff on the floor.
Hey, what did you get me for Christmas? Because you're making me nervous. It's gonna be something about egg rolls or what, the cream puffs.
Yeah, it's probably a big package of cream puffs.
I don't even know what a cream puff is.
You're about to find out. Anyways, we're doing vectors today. We are going to talk about dot products. All right, so before we get into the dot products, let's kind of rehash a few things. So let's say I have vector A is -5, 2, and vector B is, let's say, 3, 4. And let's do one more vector. Vector C, let's say that's -2, -4. Alright, so we have 3 vectors here. Now, so far what we've done as far as actual operations with vectors, we've added them. So I could do something like 3 times vector A plus 2 times vector C. So what would I do? Well, I have 3 times vector A right here, plus 2 times, I have my vector C. And then I would just go ahead and multiply that. So I get -15, 6, plus -4, -8. And then I go ahead and combine those. So -19, -2. So that would be this sum. We've done some subtraction. So I could do something like vector B minus vector A. So vector B is that 3, 4. And subtract from it vector A, -5, 2. And I've told you with subtracting vectors, switch to multiplication. Not multiplication, addition. So I'm going to distribute that negative and switch to addition. Okay, so I distributed that, switched to addition. Now I just go ahead and add those. And there's our difference right there. And then if I were showing either of these graphically, line them up tip to tail. Of course, after I multiply. Now, I want to talk about this multiplication right here. Let's just look at one of them. Let's say I wanted to do 5 times vector B. Well, we did this. We simply multiply that. 15, 20. But we didn't really give a name to it, and we probably should have. This is called a scalar multiplication. Well, what does that mean? Well, anything that's not a vector, basically when we're doing vector math, is a scalar. So, what do I mean by scalar? Well, what did it do? It scaled it up. It made it longer, right? Hence the word scalar multiplication. I could do a half there. It'd still be a scalar multiplication. It just literally scales the vector. It doesn't change the direction or anything like that. It just makes the vector longer or shorter. So what we're going to do with the dot product is we're actually going to do well, what is a dot product? Let's define that. Dot product. Let's get some synonyms here so that you know. Dot product is the same thing as saying the inner product. Let's see, is there another synonym that I need to give you? Dot product. It's also the same thing as saying scalar product. The reason for this, at least calling it a scalar product, is our answer is not a vector. A dot product gives us a scalar. So let's say I have 2 vectors. Let's use the ones from the other slide. What were they?
A equals
Vector A is what?
-5, 2.
And vector B is
3, 4.
And vector C is
-2, -4.
okay, so we're going to do some dot products. Alright, so we'll use those vectors as an example, but here's our rule for dot product. The rule for dot product is if I have any vector u dot, now I know that looks like a multiplication symbol. It's a dot product, hence the symbol. What you're going to get is the sum of ux times vx and uy times vy. So I basically multiply my x's together and I multiply my y's together and add them. Now, if I had more components than 2, I would have a z part as well, or a w, and I just keep on going. But basically, I multiply the x's, I multiply the y's, and then add those 2 answers there. So if I'm going to do vector a dot vector b, I'm going to have negative 5, 2, dot 3, 4. And then what I'm going to do is I'm going to get negative 15. See, I multiply those 2 numbers, and I multiply these 2 numbers, and then add them. So 2 times 4 is 8, and then I'm going to add those and get negative 7, and that's my scalar product. That's my dot product. Okay, so there's a dot product. Let's go ahead and do vector b dot vector c. So we're going to have 3, 4 dot negative 2, negative 4. So I'll get negative 6 plus negative 16, which is negative 22. That's my dot product. So remember, for dot product, you multiply your x's, you multiply your y's, and that. The answer is a scalar. You don't get, when you do a vector when you do a dot product, you don't get another vector. Now when we do another, there's another type of product that we can do that is different. So there actually is a difference. We aren't going to do this today, but I just want to highlight there's a difference between, now you don't learn this in elementary school or even Algebra 2, but this symbol technically does not mean the same thing as this symbol as far as multiplication. Now you learn like 5 times 2 is the same thing as 5.2 is the same thing as this. You learn that those are all the same, and when you're talking about scalars, that's the case. These are all the same. But when you're talking about vectors, this thing is different than this thing. Those will mean to do different things, so you're going to have to keep that straight. So right now we're just doing the dot one, and our answer is simply a number. Alright, so our dot product is actually going to give us some useful information. And the first useful information it's going to give us is going to tell us if vectors are orthogonal. Well, what is an orthogonal vector? Well, that's a long word to say something that's pretty simple. It means they are perpendicular. Well, then when you read this word in your textbook or somewhere else, you're going, what's orthogonal? Okay, orthogonal vectors are perpendicular vectors. Now, the dot product is, now in 2 dimensions, that's pretty easy to see. Like, here's, you know, those are all okay, so here's a vector, okay, and here's another vector. And we can quite easily see that those are perpendicular. Even if they're not, you know, right next to each other, I can see that those 2 vectors are perpendicular. Alright? The dot product is going to tell us that without us drawing it or anything. Okay? You with me? So, what I might be asked is a question like this. Are the vectors orthogonal? Or you might be asked, do they form a right angle? Or you might be asked, are they perpendicular? So let's say vector C is 2, 3, And vector D is, let's say, negative 6, 4. All right, well, I'll do my dot product. So I do my dot product, I get negative 12 plus 12, and I get 0. So here's what orthogonals have, the important thing. They're dot products equal 0. So if I were to sketch those two vectors really quick, shoot, negative 6 is way over here. 2, 3. I might not be able to finish. Do it. Okay, so 2, 3. 2, 3. Boom. This vector. Negative 6, 4. Right there. We can see that those, even in my rough sketch, those appear to form a right angle, right?
So if it ever equals 0, it's an orthogonal vector.
Right. And if it doesn't equal 0, then it's not orthogonal. So it's a pretty simple test to do.
It sounds like an ogre's name.
Donkey.
Orthogonal.
Orthogonal.
Orthogonal the third.
Okay. Last thing for today, finding the angle between vectors. And okay, so just pay attention to my thinking process right here. Let's say I have a vector and I've just drawn it in its at the origin. Here's a vector and here's another vector. And what I want to know essentially is, well, what's this right here? What's this angle? Now you can answer this question without what I'm about to show you, without the formula that I'm going to give you. Let's walk through that thinking, how you would do this without it. Let's say I had, let me tell you some things about this vector. Let's say this vector, so we'll call this is vector A, and let's say this is vector B. And let's say vector A is 5, 1, and let's say vector B, let's say that is 3, 5. Sure. Okay? So here's how we would do this without the formula. I would first find this angle. I'd first find the direction of A. Watch my thinking right here. I would find the direction of A. So I'd find this angle. Oh, I meant that to be a different color. I guess I have to use this one. Can you see that? So I'd first find this angle. So this is my A angle, right? And then I would find my B angle, right? And then if I subtract those, won't that give me this angle right here? Do you get what I'm saying? So that's what I would do. So, well, how do I find the angle of vector A? Right? 1 over 5. Inverse tan that. And what's the inverse tan of 1 over 5 to the nearest 10th?
11.31.
Okay, nearest hundredth, sure. So that is this angle right here that this makes with the x-axis. And then I do the same thing for B. And what's the inverse tan of 5 over 3?
59.03.
Okay, and so what have I found? I found this angle. What's this angle? From the x-axis up to here. So what I'm saying, if I subtract those, then I'll get the angle between these two vectors. So I do my 59.03, minus 11.31. And what do I get?
$47.72.
So that's the angle between those two vectors, doing it like this way. Now, let me give you the formula that we can use. It's not necessarily intuitive. This is a straight up memorize. So if we want to quickly find the angle between two vectors, we're going to say the cosine of the angle between them is going to be the first vector, we'll call it vector u, dot the second vector all over the product of their magnitudes. Well, you can see the next step is going to be to inverse cosine, right? So we'd inverse cosine that. So if you want the angle directly, you're going to end up inverse cosining that stuff. I'm not really liking this UV thing. They all look the same. So let's go ahead and do that. So we got, by our little trigonomic method right there, well, this is also a trigonomic method, but by straight up reasoning, drawing, and everything, let's see if we can replicate that answer. Oops, I didn't want to erase those vectors. Okay, I want to know what they are. Okay, can I get this answer? Just give up on life. Okay. Okay, let's see if I can get the same answer by this formula. So cosine of theta, I'm going to dot those two things. So A dot B, so I'm going to have vector A dot vector B, because those are my two vectors. I'm going to find the magnitude of A, and I'm going to multiply it by the magnitude of B. Then I'll inverse cosine that. So, well, what is A dot B? I'll do it over here. A dot B is going to be 15 plus 5, so 20. So I get 20 in the numerator. Right? I need the magnitude of A. Well, the magnitude of A is going to be the square root of 25 plus 1. So root 26. So I have root 26 in my denominator times another root. I need the magnitude of B. So the magnitude of B is going to be the square root of 9 plus 25, so root 34. Okay? So now, because I'm ultimately finding the angle, there is no reason to simplify this. Okay? I just need to put it in my calculator really carefully. So I'm going to do theta equals inverse cosine. Now when I type this in my calculator, I'm going to be very careful of my parentheses. It's going to be 20 divided by the quantity root 26 times root 34. Some calculators, you may need to be even extra careful and put a parenthesis around each of these additionally. So we should get that 47.72, unless we have made a horrendous error somewhere. What do we get?
47.72. But they would round up to 73.
Yes, you would round. But yeah, we got the same thing,
Okay.
in essence. That's what I'm getting at. Okay, so let's do one more. Let's say my vector, let's say vector C is 3, 4. And let's say vector B is 5, 2. And I want to know, well, what's the angle? Is that the same vectors? No. Okay, good. Let's say I want to find the angle between these two vectors. Now, because we skipped over the previous chapter temporarily, there is a third way to find the angle between vectors. That would be the law of cosines, but we're going to go back to that. So we're going to write our formula. You need to memorize this formula. Vector u dot vector v.
What do you use you?
I don't know, because I'm mimicking what the book does. It doesn't matter. The essence is I do the dot product over the magnitudes. That's how you do it. So our dot product is going to be 15 plus 8. Our magnitude of C is going to be 5. And our magnitude of B is root 29. So I'm going to inverse cosine that. So I'm going to do inverse cosine of 23 over 5 root 29. And put that in your calculator very carefully. Again, some calculators you're going to want to have this extra parenthesis right there to make sure that this is working correctly. And what do we get for our angle between the two vectors?
I got 31.3.
That's what I got.
Yeah.
Okay, sounds good.